So web-coded project OpenClaw went from having one file to having this in 3 months. And I was trying to understand like the evolution of what was happening under the hood. And like when you wipe code some project, basically over time, it will become harder and harder to add new features to kind of interact with AI, because it will be kind of like getting confused more and more just because the project grows, and it will be harder for AI to understand what happens. But in case of OpenClaw, it's pretty successful project commercially. It's used on production by many people, and it was able to move fast in terms of development speed. So we can see here like 15,000 commits. And I was trying to understand how it was possible. And one of the primary reasons from technical perspective is architecture. So I created this like architecture evolution visualization. We'll go through it today. Basically, I wanted to visualize how this project progressed, like how the architecture progressed over time, to understand how OpenClaw was able to maintain this like development velocity without breaking, without having like unmaintainable mess that needs to be rewritten, this kind of stuff. And the other reason why I got interested in this is after seeing number of contributions in Peter's account. So this is Peter, creator of OpenClaw. And so 93,000 contributions. And when I saw it, I was like, I think I was staring for like 5 minutes and trying to understand how is this possible. Because to put in the perspective on my account, when I worked at like early stage AI startup, it was 7,000 contributions. And I thought it's a lot because, well, it was a lot of code being written, but it's nowhere near what Peter is doing. And one of the reasons, like I was trying to dig deeper into his workflows. So he publishes blog posts and he also explains in interviews like his dev workflow. But one of the like reasons behind this is clean architecture, how it was created, how it was maintained over time. So in this video, kind of we'll go over architecture of OpenClaw and mainly how it evolved. So first of all, this graph, it's open source project. I found it's GitNexus. Check it out. It's pretty, I like the visualization that it does. But in case of OpenClaw, it's kind of big project. So for example, here, there's a lot of functions, files, and it's hard to just like reverse engineer what's going on from this final state. That's why I wanted to kind of explore what was happening gradually over time. And this visualization is effectively, I took like every 1,000 commits, I took a snapshot of the repository and visualized it here. So root, this circle is a folder. For example, let's take this infra. So SRC infra, you can see it's a folder and an explanation. This explanation is from Claude. Okay, and those arrows are dependencies. So essentially, when one module imports another, it makes an error here. And this at the top is like a high-level explanation of what was happening, like what was going on in terms of architecture. Okay, so let's go through it. So again, OpenClaw started. So November, it's like there were a couple of files. So you can see here. So there's no architecture. Essentially, it was just like, okay, so WhatsApp, where you can send the message, and AI was responding. On November 24th. Next, December 9, we got layers. So layered architecture, essentially, like when AI writes code, it needs to put it into some buckets. So files, folders, and those buckets can be grouped in certain layers. So this is so-called layered architecture. but it essentially means like, okay, we need a Telegram integration. We need to write code from Telegram. Where do we put it? Well, it would make sense to put it into like something that represents kind of like communication channels, because we will have like WhatsApp and Slack. They are all communication channels. So it makes sense to group them together so that it has kind of clear structure instead of just like writing one big file or adding everything to random files. It will become like very unmaintainable at some point. Okay, layered foundation. Yeah, gateway. And so single file got into like 14 modules. So we can see here channels, again, like Telegram. So WhatsApp will go here, Slack, core. This is like, okay, the logic of EI replies, EI routing. Then EI media. So media is for images, right? And then infrastructure, CLI comments, and the root. So this is imports of files and this process thing. Okay, this is December 9. Next, December 21st, we've got web browser, a bunch of new features, and you can see here this like layered approach. Let's go further. January 4th. So you can see here channels. We got Discord, Telegram, Slack. They were grouped under this channel. Now core, EI, media. We got browser. That's interesting. Okay, January 4. So this is every 1,000 commits. So previous was 3,000 commits and then 4,000 commits. We got more integrations. Okay, core. And this is kind of, so this is for Cloud Code. Essentially, it was taking snapshot and kind of was figuring out how the platform was changing. One of the, we'll get to the one interesting point, which is plugin architecture. It happened later. I think it was one of the most interesting points. Okay, platform maturity. Work in the foundation. There was refactor. Yeah, this one, plugin architecture. So essentially, at some point, Peter needed to like integrate many third-party like contribution pull requests, and with every new feature, like it wasn't always clear where to put new things. So instead of creating mess, like it's a common pattern to use plugin architecture. For example, in VS Code, there are plugin like extensions. They're called extensions, but it's a plugin architecture. So many people create like VS Code extension to, I don't know, format Python code, whatever. And this code doesn't sit in VS Code repository. So I don't need to open like pull request for VS Code. Instead, I create a separate plugin and it kind of connects to VS Code. So here in OpenClaw, there was a similar idea to have extensions, right? And if I go further, a couple of milestones, you can see here it blew up at some point. So there's like dozens of new extensions, extension boom. Essentially, Zalo. I don't even know most of the things what they mean. It's Zalo or some kind of platform. This one is for encryptions, but you can see here this grouping by layers is very important. Otherwise, we would have got like few files and then everything is spaghetti. It's not clear how it's connected. But instead, we got this very clear grouping, and like this architecture was one of the reasons like why OpenClaw was able to maintain this like development velocity. And this is only like January 20. So we started with December 2025. So it's like 1 month in, and it's pretty big evolution. So 77 modules now. This ecosystem. Yeah, a bunch of new plugins. Okay, let's go further. February, this is refactoring. Refactoring is also very important. 25 cleanup commits. So there was also one point that I found interesting is this. So you can see February 16. So there was like type safety refactoring, and then 1,000 commits later, it is still February 16. Security hardening. So there was a lot of like security issues. So February 16, there was security hardening, but this like the difference, like 1,000 commits later, is still the same day. So it's like insane development velocity, right? And we can see here this like plugin ecosystem layer. I'll disable the arrows because they are, so this plugin ecosystem. So plugins go here. Core, this is like general infrastructure. You can see here, brain of the whole system, because the right model executes with these agents. Then this gateway. So the gateway is for like communication channels, discords, and so on. It's like core stuff. Then there's memory management, infrastructure, CLI. Yeah. Okay, stabilization here, maintenance mode. Let's go to the final stage, living system. So as you can see here, if I scroll here, there's like more and more of those plugins. I think this is one of the most interesting parts. When it became like plugin architecture, it's now very, very cool. For example, this Twitch plugin. If you want Twitch channel and if you want AI agent in your Twitch channel, then there's a plugin. So we didn't need to figure out, okay, where do I add code for Twitch? Like, does it go to which file it goes? It's pretty clear that it can be connected as an extension, right? Telegram lives here in channels. Tweaks. So yeah, now it becomes like more stable architecture. And again, as I go back here, it's like 3 months only passed. So pretty fast pace. And this architecture, like it wasn't like plugin architecture from day one. There was no like core infrastructure from day one. Day one is what it was very simple, but it couldn't go on like this. Like Peter couldn't just add everything on top of this file. It would have become just like unmaintainable. So yeah, pretty cool to see how this project is like structured under the hood. So again, those circles are folders, right? And yeah, this honestly looks pretty clean and a million lines of code. So yeah, over 3 months, it's very fast pace. And again, the coolest thing is this is like the code itself was vibe coded. The lines of code were vibe coded. But the architecture itself, like the decisions, okay, where would it go? How would we restructure? Okay, we need a plugin architecture. Then they were made by Peter, who was essentially like in the driver's seat, architecting this driving. And yeah, this is, I think, one of the reasons, like from technical perspective, how OpenClaw is able to maintain this development velocity.